All right, today we start chapter 2.3, which is all about polynomial division. We use polynomial division when we're trying to find zeros of any function or if we're just trying to get a function factored out further. So just a reminder, we've been talking about this quite a bit, but finding zeros of any function, whether it's polynomial or we'll be doing rational, exponential, logarithmic, trig, any function, if you're trying to find the zeros, you're being asked to do a lot of different things. Well, not different things. You're being asked to do the same thing several different ways. Find x-intercepts, meaning determine where the graph crosses the x-axis, or maybe they're asking you to solve, let's just call it f of x equals 0. That's another way to find the zeros. You might be asked to factor completely. And then solve the equation above. So finding the zeros, just a reminder, whether or not you can factor, you're trying to find x-intercepts, you're trying to figure out when is the function equal to 0, when does it cross the x-axis, zeros just in general for any function, or where is that function touching the x-axis. So normally, like I said, we factor completely and then we solve. But what if the polynomial isn't easily factored? So we can't factor by grouping. It's not a trinomial. It's not a difference of squares or cubes. So this is where polynomial long division comes in and kind of saves the day. So rather than writing out the steps for long division, because I think it's kind of hard to write it out in words and have that be helpful in any sort of way, I just want to take you through some examples. Find all the real zeros of the function given the following information. So we have this f of x, and we're told that x minus 2 is a factor of f of x. That means that if you set x minus 2 equal to 0, x equals 2 is a 0 of f of x. So that's important. If we're given a factor, we're also given a 0. We just have a little bit of solving to do. And before I get started, I just want to note, factoring is obviously my preferred method. But I just want to note, I can't factor by grouping here because even though I can take out an x squared from the first two terms, and even though I could take out a 4 from the last two terms, factor by grouping doesn't work if you, or doesn't really get you anywhere, I should say, if you don't have the same expression in parentheses, because there's no GCF to factor further. Okay, so here's long division setup. We put our divisor outside of a long division setup here, and we put our f of x, 6x to the third minus 19x squared plus 16x minus 4, put that underneath. And you're just looking at the first term of the divisor and the first term of the, I think this is the dividend. And you're just saying, what would I need to multiply x by to get 6x to the third? Or another way to think of that is, what is 6x to the third divided by x? That answer is 6x squared. So however you want to think of it, either do this division or say, what would I have to multiply x by to get 6x to the third? I would have to multiply it by 6x squared. So that result goes above the 6x to the third. And then once you've determined that, you multiply 6x squared times x minus 2. So 6x to the third. 6x squared times negative 2 is minus 12x squared. Put that result below the terms that match up with the same degree, so keep everything lined up nicely. And then think about normal long division. Once you have a number down here, you're supposed to subtract. Subtract with parentheses. I usually use the parentheses instead of physically changing the signs, especially if you have messy handwriting. It can be really hard to read your handwriting if you're just going through and like writing over minus signs and changing them to plus. So we're advanced enough in AP Pre-Calculus. We can think about minus negatives correctly, I think. So 6x cubed minus 6x cubed, the first term should always cancel out. You've set it up to be that way. Negative 19x squared minus negative 12x squared. So really this is negative 19 plus 12 is negative 7x squared. And once you're finished subtracting, you drop down the next term in line, just one term at a time. So I should have two terms here if I'm dividing by something that just has two terms. And then you repeat the process. So what would we multiply x by to get negative 7x squared? Or off to the side again, you can think of what is negative 7x squared, including the sign there, divided by x. It's negative 7x. So it is minus 7x that I put up here. In other words, I usually use the what would I multiply by. So I would multiply x by negative 7x to get negative 7x squared. And then we take just the negative 7x and multiply it by x minus 2. So negative 7x times x, negative 7x squared, negative 7x times negative 2, plus 14x. With long division, just be very mindful of your signs and paying attention, making sure you're getting those correct. Negative 7x squared plus 7x squared cancels out, should be 0. 16x minus 14x is 2x. Drop down the last term, which is minus 4. What would we multiply x by to get 2x? 2. Or in other words, what's 2x divided by x? 2. Make sure you're writing, if it's positive, a plus 2 in front of that. If your result is negative, a minus. And then multiply 2 times x minus 2. You get 2x minus 4. An expression minus itself cancels out to 0. So that means that because x minus 2 is a factor of f of x, it should divide in perfectly, and we should always end at 0. So our answer we're finding all the real zeros here. So far what we have, sorry, I'm going to erase this work off to the side here. Actually, no, I don't want to do that. Come back. Okay, so what we've just shown is that now we have a factored form of f of x. We divided f of x by x minus 2. And our quotient, our result, was that it should be 6x squared minus 7x plus 2. Now that we have a quadratic, we're trying to find zeros, we should be able to either factor this or use quadratic formula. So let's see. I'm going to try the factoring route. It's probably 3x and 2x. Yeah, and then if we put 2 and 1, we get 4 and 3. And if they're both minus 4x minus 3x is the minus 7x we need. So if these three factors are equal to 0, then finally we get to our zeros. X equals 2, x equals add 2 divided by 3, 2/3, and positive 1/2. So the question said, I almost stopped at the division, but the question said find all the real zeros, so we just did that. Now, number 2, normally I would factor this. This is an easy difference of cubes, right? But I do just want to show you how the division can work as well. So, especially when they give you a 0 that's a fraction. So, thinking about how this factors, if we're told that x equals 1/2 is a 0 of the function, that's kind of going backwards from what I did in the first problem. I gave you a factor in the first problem. Here I'm giving you a 0, so you do kind of have to work backwards. If you're supposed to do division, given a 0, you need to come up with what the factor is. Now, it could be x minus 1/2, but because this is not x to the third, this is 8x to the third, we should make it 2x minus 1. So our factor is going to be 2x minus 1. If we would have made it x minus 1/2, then we'd have a 1/2 to deal with in long division. That's kind of ugly too. So 2x minus 1. And now that we have our factor, we can set up our long division. Here's another reason I want to do long division with this one. This problem, unlike the previous problem, is missing some terms between its highest degree and its constant degree. You need to fill those in with placeholders or zeros. So we have 8x to the third, but I need everything to line up nicely in long division. So I'm going to write plus 0x squared plus 0x, and then it ends with a minus 1. We do that for any function that's missing, even if it's just missing one term, like just the x term or just the x squared. You fill it in with a placeholder. And then you should be all set up and ready to go. So what do we multiply 2x by to get 8x to the third? 4x squared. And then we multiply 4x squared times 2x minus 1. We get 8x to the third minus 4x squared. Subtract the quantity. Here's where the placeholder makes a difference. You have something to line up your x squareds with. This is 0 plus 4, so that's 4x squared. Drop down the 0x. Even though it's 0, we still drop it down so everything lines up nicely. And then we repeat the process. So what do we multiply 2x by to get 4x squared? We multiply by positive 2x. And then multiply 2x by 2x minus 1. So 4x squared minus 2x. Subtract the quantity. 4x squareds cancel. 0 plus 2x is 2x. Drop down the minus 1. You're not finished with long division until you are left with something that is 1 degree lower than what you have. So I can still do one more round here. What do I multiply 2x by to get 2x? I multiply it by positive 1. Multiply 2x minus 1 times positive 1. Subtract, you get 0 again. Remember, we're supposed to be getting 0 for these because the values that we're dividing by are factors, which mean that a factor of something means that it divides into it nicely without a remainder. We're supposed to be finding all the zeros. So now we have this y factored into 2x minus, y equals the factor that we divided by, 2x minus 1, times our quotient, 4x squared plus 2x plus 1. Now that does not factor. I have find all the real zeros. I know from my previous Algebra 2 work, I don't know if you remember this or not, or if we've talked about it this year. When you're doing a difference of cubes, this trinomial that's the result of that is always something imaginary or complex. We can show that. We haven't really talked about imaginary numbers yet. That's our next section, but we might as well just get into it. So if y equals 0, then x equals 1/2 is a 0. We were given that. And then what about these? We're only supposed to find real zeros, but I just want to show this real quick. I would do a nice little quadratic formula. Do this over here. -2 plus or minus square root of 4, that's 2 squared, minus 4 times 4 times 1, all over 2 times 4. -2 plus or minus, so this is the square root of 4 minus 16. That's the square root of -12. So again, we'll talk about this next section, but you probably worked a lot with imaginary numbers last year. So if you remember, instead of 2 radical 3, it's 2i radical 3 divided by 8. And then last thing about quadratic formula, we've had quadratic formula quite a bit. Remember, if you're going to reduce this, you need to reduce all the 2, and the 8. You can't just do one set 2 over 8. So divide everything by 2, and you get -1 plus or minus I radical 3 over 4. Now, again, this is just like sidebar. The directions were find all of the real zeros. So your 1/2 is the only real 0. These other 2 are imaginary. Okay, and then you might have also learned, I know you learned long division last year in Algebra 2, you might have also learned synthetic division. Synthetic division is not required for our AP test, but you're allowed to use it. And it's a shortcut, but there is a rule here. We can only use synthetic division if we're dividing by a linear factor. So if this would have said x squared minus 2 is a factor, we can't use synthetic division. So this is a shortcut. only for x minus k linear factors. Okay, repeat the same two examples. So same thing, we know what the answer should be using synthetic division. Be careful using synthetic division with zeros that are fractions. So we'll get to that in a second. Again, instead of writing out the steps for synthetic, I just want to show you the setup. It's easier to just see how it works. First, find your zero if it's not given. So x minus 2 is a factor. That means that x equals 2 is the zero. Put the zero number only outside of a synthetic division setup, which looks like this. Part of the reason this is a shortcut is because we're just using coefficients instead of all the x's. So just use the 6, just the negative 19, just the 16, just the negative 4. And then the way this works, once you get it set up, you will always drop down the first number and write it below the line there. And then for synthetic division, it's multiply, add. Multiply, can't write multiply, add, etc., etc. So multiply 2 times 6, write that result below the next number. Add, negative 19 plus 12 is negative 7. Multiply 2 times negative 7, negative 14. Add, 16 plus negative 14 is positive 2. Multiply 2 times 2. Add, negative 4 plus 4 is 0. What you're left with are the coefficients of the quotient. So here's how we translate this back into our factored function. F of x is x minus 2. We divided by a 0 of 2, so factor came from x minus 2. And our results here, this is the remainder. There was no remainder. This is always the constant term. This is the x to the first term, x squared. If we had more numbers, like a longer list of numbers, again, starting on the far right is the remainder, constant, x, then it just counts up 1 degree each time. So this is showing me that it's 6x squared minus 7x plus 2. And we know from before that setting that equal to 0, the factoring was 3x minus 2 times 2x minus 1. And we get the same set of zeros. 2, 2/3, 1/2. Okay, what am I saying with the be careful thing out here? Now, we wrote the factor as 2x minus 1 when we did long division. That was good. Here, I have a fraction that is the 0, and so I'll be putting a fraction outside of synthetic division, which is fine and totally legal. We just have to kind of be careful when we come to our factoring. And the placeholders are still a thing. So we need placeholders where we're missing terms. So we start with our 8, but then there's 0x squared, there's 0x, and then there's a constant term minus 1. And then you drop down the first number, you multiply 1/2 times 8, and then you add 0 plus 4. Multiply 1/2 times 4, add 0 plus 2. Multiply 1/2 times 2, add negative 1 plus 1. So this one's kind of different, right? Because remember what I showed the factoring to be? Here we're getting y equals, so technically this would be x minus 1/2. When you do synthetic division, you do use the fraction here temporarily. Remember, this is the remainder, constant, x squared. So we have 8x squared plus 4x plus 2. Remember, when we did it long division style, we had 2x minus 1, not x minus 2. And we had 4x squared, 2x and 1. So all we have to do on this one is factor out the GCF of 2. Like that. And then I don't love having a 2 times x minus 1/2, so why don't we distribute that back through just to get rid of the fraction, and we get to the same spot. Now, does it really matter? Because we're just trying to find zeros, and the answer to that is no. You can still find the zeros, whether you distribute this back through or not. But the important thing is that if you were to multiply your factored result back together, you have to get back to the original polynomial. If you somehow missed that this 2 existed or somehow didn't have an 8 or whatever, if you multiplied it back together and you got like x to the third instead of 8x to the third, or 4x to the third instead of x to the third, that would be a problem. So maybe if you factor the 2 out but forget to write it back down, that wouldn't be correct as far as factoring goes. Okay, and then we know from the previous problem, x equals 1/2 is the only real solution. These are imaginary. I'm not going to do quadratic formula again for those. And example 4 just says divide, so it doesn't say find all the real zeros, it just says divide. And remember, we're taking this numerator divided by this denominator, so the divisor is not linear, it's x squared, it's actually quadratic, so that means that we can't use synthetic division. Synthetic division only works for linear factors. So we're going to set up long division for this. X squared plus 2x minus 3 is the divisor. The dividend is 2x to the 4th. Your terms do need to be in standard form, by the way, so if the textbook for our homework, if they try to trick us by putting things out of order, make sure you rearrange it. And so we're saying, what do we multiply x squared by to get 2x to the 4th? We multiply by 2x squared. And then 2x squared needs to get multiplied to all 3 of those terms. We write that result down below. 2x squared times 2x is plus 4x to the 3rd. 2x squared times negative 3 is minus 6x squared. Subtract the quantity. Now, if you want to go through and change all of your signs, maybe you learned that last year, that's totally fine. It's just however you can correctly get the signs. That's the most important part. So 2x to the 4th minus 2x to the 4th is 0. 4x cubed minus itself is 0. Negative 5 plus 6 is 1x squared. And because my divisor is 3 terms, I need to drop down the next 2 terms so that I have enough terms to line up correctly. So this time we drop down 2. And what do we multiply x squared by to get x squared? We multiply by 1, so plus 1 up there. When you multiply this trinomial times 1, you get x squared plus 2x minus 3. Now this is not the same exact trinomial, so we will have some terms left over. We do 3x minus 2x is x. Negative 2 plus 3 is plus 1. And I have to stop here because we're 1 degree lower than what we're dividing into. If we start saying, what do we multiply x squared by to get x, we're going to say like x to the negative 1, and that's getting complicated. So how do we write our answer here? Well, this is the remainder. And so we write the remainder. Think about if you divide like 49 divided by 12, that's 4 and 1/12. So the remainder becomes a fraction. Same thing here. We would say the quotient is 2x squared plus 1 plus x plus 1 over what I was dividing by. So if we were to multiply x squared plus 2x minus 3 back through these 3 terms that I just wrote out, we should get the original numerator, that 2x to the 4th polynomial. Okay, this brings us to the remainder theorem. So if a polynomial, f of x, is divided by x minus k, so x minus k doesn't have to be a factor, it's just some expression, then the remainder r is f of k. So what does that mean? It means that the remainder is equal to what we get when we evaluate f of k. Okay, so what does that mean? It means if you go through synthetic division, back to these ones, if I say do synthetic division on f of x here, when x minus 2 is a factor, when x equals 2 is a 0, the fact that the remainder came out to 0, that means that f of 2 is equal to 0. If we plug 2 into this polynomial, it should calculate out to 0. So that's kind of nice because that's a shorthand, usually a quicker way of evaluating a function if the exponents are high. Same thing here. This is saying because we got 0 as a remainder, this tells me that y of 1/2 is equal to 0. So we can do a very quick little proof for this. So let's say q of x is the quotient. It's what we had at the top when we did our division. And so we did long division so that f of x, if we put it in its factored form, is the thing we divided by times the quotient plus the remainder. So divisor times quotient plus remainder. And the reason those are all functions is because, yeah, the divisor is some function, the quotient is some function, the remainder can be a function, it doesn't have to be a number. So all this is saying is, if this is true, when we plug k into f of x, we should just be left with r. So let's look at that. Plug k in for every x, k minus k times q of k plus r of k. Well, k minus k is 0. So f of k is going to equal r of k. And r of k is just going to be some sort of number because you're plugging a number into an expression. So yeah, what's so great about the remainder theorem? It's a sometimes faster, kind of depends, but sometimes faster way to evaluate functions. So now when you see evaluate f of c, one way is the old way, plug in c, simplify. The new way is to do synthetic division with c on the outside, and then the remainder spot is equal to f of c. So we're going to practice that. Use the remainder theorem to evaluate. So f of -2, again, I could just plug -2 in. That wouldn't be terrible. But using our new method, we should be able to put -2 outside of our synthetic division setup. Drop down our first number, multiply, add, multiply, add, multiply, add. Remember that the number furthest to the right is the remainder. So f of -2, excuse me, is equal to -9. If we check the math on that, again, the old way to do this, to figure out f of -2, would be plug in, trying to write here, plug in -2. 3 times -8 plus 8 times 4 plus 5 times -2 minus 7. So the argument here is like, well, this math is a bit more cumbersome because not that it's incredibly hard, but I've had to raise the exponent. I've had to raise a number to different exponents, keep track of the positive and negatives, had to multiply. Now I have to struggle through my addition and subtraction here. So let's see. -24 plus 32 is 8. 8 minus 17 is -9. So was that incredibly long, so much longer than the other way? No. But synthetic division is just multiply, add, multiply, add. So yeah, you might get some big numbers, but kind of nice. Let's just do this one with synthetic division. I'm not going to show the traditional method. Same function, so same starting coefficients, new number on the outside. So drop down, multiply, add, multiply. So yeah, I may have to do some multiplication off to the side. I don't think that's a big deal. Add, multiply, add, So it should be that f of 3 is 161. In interest of time, I'm not going to plug 3 in and go from there. We could hop over to our calculators and type in the function and figure it out, or hop over to Desmos. But one last thing to talk about is the factor theorem. Really, this is just the remainder theorem. And it just says, hey, if this happens to come out to be 0, if f of k happens to be 0, then the thing you were dividing by must be a factor, not just some random thing we're dividing by. Okay, so what does this say? Since we know that r equals f of k, if r equals 0, if you're doing synthetic division and r equals 0, then that means that k is a 0 of f of x. And then if you go backwards, x minus k is a factor of f of x. A factor means that it divides nicely without a remainder. So show that x minus 2 and x minus 3 are factors of this thing. All right, now we have options here. We can use synthetic division. It doesn't matter which order we go in. These are both linear factors. So I'm just going to start with synthetic division. I'm not missing any terms that I can see. Because I know that x minus 2 is a factor, I should end with 0 right here. So let's just see if I can do the math correctly here. Drop down, multiply, add, multiply, add, multiply, add, multiply, add. Good. So far, so good. Here's what we have so far. You don't have to write this, but here's what we have so far. This fourth degree polynomial has now been factored a little bit into x minus 2. And then, let's see, I guess I'm writing this out, but if we just divided a degree 4 by a degree 1, we should end up with a cubic. So here's what we have so far. I do kind of like writing this out, just in case what I'm left with is something that would factor by grouping. I think that's kind of nice. So far, x minus 2 is a factor because we got 0 remainder, so great. And then we're supposed to do a second round. Now, divide what you have left. You're whittling this thing down, so don't go back to the original. Divide what you have left by the other factor. So put the 3 out there. Use these coefficients, not the originals. And again, we should get 0 right here because x minus 3 is supposed to be a factor of this thing. Drop down, multiply, add. Oh, I feel like it's not going to work. Hold on. Did I do something wrong here? Multiply, add 17, 3 times 17. Yeah, there are no negatives here. I wonder if my problem is flawed. Okay, well, I'm going to put a pin in this, and we'll be fixing this in class. What was the other method that I wanted to show you, though? Because it should be that I get 0, and then I get something I can factor down. I bet I have a typo somewhere. Here's another way we can kind of check this. Second method. FOIL together the two factors. X minus 2 times x minus 3 is equal to x squared minus 5x plus 6. We could use long division instead of 2 rounds of synthetic to just knock this thing out right away. So let's just see what happens, because again, I think I've got a typo somewhere, but you're dividing the original by both of these factors, which we've already multiplied together. So let's see, we would multiply x squared by 2x squared. Subtract this quantity. 7 plus 10 is 17, x cubed. Negative 4 minus 12 is negative 16, x squared. So yeah, I'm getting things to match up. It's not looking, I'm sure I've got a typo somewhere. It's not looking great. We would multiply by 17x minus, let's see, 530, 85x squared plus, let's see, tag another 17 onto that. 105x. Oof. All right. Things are getting kind of ugly here. So There must be a typo. Okay, but if this could go on, if this worked out nicely, if I were to get a zero remainder here, then I would have the factored out version, or I'd have some sort of quadratic that I could factor further from there. We did show that x minus 2 is a factor, so maybe this was supposed to be x plus 3 or something. I could play around with that. But I'm going to stop the video there rather than correcting it because I'm sure I'm starting to run out of my time. But anyway, if I got 0 here and I got 0 here, this would be some sort of quadratic. And we know how to factor and solve quadratics or use quadratic formula. So we would be finished with the problem at that point. But for now, I'm just going to write x minus 3, not a factor of that polynomial. All right, sorry for the typo. We'll figure this out in class.